Hello everyone, it's June 29th. Um, so at work, finish up some stuff, and then we're trying to start something new. And that something new is really new to me. I'm gonna use something called Spark and Delta Table. It's something that my current manager is really trying to push. So we'll see how that will go. But before we start on that new thing, basically we try to rewrite part of the data pipeline to make it faster. So it'll be a very interesting learning experience. I'm actually very much looking forward to it. Right now, I'm trying to set up the tests. I'm very heavy now on the tests. Having good test cases is so important. It's probably one of the most important thing because things change, how you implement things change, but the final goal stays the same. So if I can, for every task, set up the final goal, which is the test case, and I don't even care how I implement the process, as long as the final thing is correct, then we're happy. So this is what I'm doing right now, basically trying to set up the test case. Now the test case I'm trying to set up right now is it's actually a little bit more complicated than I had wanted. So we want to rewrite almost like rewrite this a specific part of the data pipeline, and the end point of the data pipeline is in Elasticsearch. So I have been running some local Elasticsearch, for regular, just proof of concept or whatnot. But now I need to basically write a new version of the current data pipeline. Then I want to test whether the new version does exactly the same thing as the old version. So I need to run two instances of Elasticsearch on my local machine. And one will be fitted with the new code and the other with old code. And then we can run a test, just trying to pull the data from both Elasticsearch instances and compare them. Now, I want to do this on Docker, but I also don't want to spend too much time learning how to set up the network in Docker. So very naively, I was like, okay, I just set up do two Docker runs, and I think that's two containers, right? I'm not sure. I think that's two containers into the same network, and I did expose the local to the host machine. To the host machine, the IP the port is different for both, so I can access them differently, which is what I wanted. But both of them use the default Elasticsearch port, which is 9200. So since both of them are using the same, and I think they're on the same network, so once I spin up one container, the other container shuts down, which is understandable because they're on the same network. So what I think I need to do, if I want to run two independent Elasticsearch instances on Docker, I need to create at least one more network. So one network will be just a default local network, and the other will be whatever network I set up. So I have two networks, and I can run two independent Elasticsearch. But I just feel a little bit lazy, feel just a little bit lazy. So I'm resisting. But maybe, yeah, I just think back. I think it's actually a good thing to do two networks. Not even using the local one, just use the two networks. I can do a compose, a Docker file and do Docker compose to set up two independent containers, possibly in two different pods. And then, wait, hold on, is pod and container the same thing? I am still confused on the Docker. So tomorrow maybe I'll try to do that. The reason being, by doing that, all the configuration is in one file. So I just run this one file. I set up two instances, and then it will be just so much easier to handle everything. So yeah, that's what I'm trying to do. Trying to set up the tests. Very important. All right. Anyway, so this is what I've been doing today. So today's goal for here is definitely finish this one, And then we're going to try to go back to this one again. We might need some help. We might need some help on this. I don't even remember what I did in the past. So I have to redo this. My God, I have to redo this. Anyway, what's this one? Minimum moves to equal array elements. Number 2. Given an array nums of size n, the minimum number of moves required to make all array elements equal. In one move, you can increment or decrement element of the array by 1. Test case is designed so that answer will fit in a 32-bit integer. So we want the minimum number of moves. That this needs 2 moves. Yes, this needs 16 moves. Okay, so what do you think? Let's sort the array first. That's my first instinct, right? When it's sorted. And then what? Well, if we sorted it, is it true? Because we want to move them to a value, right? So that could be any value. Isn't that just a sum? If we do 1 plus 2 plus 3, that's 6, right? And then we do some moves. If everything wants to be 2, that's 6 as well. So we have no change. Now what does that mean? That just means the amount of values added to this, it equals the amount of minus on the other side. Well, I mean, it is okay, right? So basically, one way to do this is we just, and the values can repeat themselves, right? And they can repeat themselves. So what I can have is the unique values and their sum. Okay, we'll have the sum. And then I can say if I pick one, then everybody else has to conform to that. So we have the total remaining sum, right? For the smaller and for the bigger. So for this, let's say for the smaller a certain value, for the bigger a certain value. And then we add them together, right? And then once we add them together, okay, once we add them together, we can minus. So that's the total we have to do. Are you telling me that we can do a prefix sum? Okay, we do a prefix sum, and that's on, and then we iterate through for each value. We take the sum on the front and the sum on the back, and then we do a minus, and then see how which one is the smallest. Let's try that idea. I find this idea compelling. Wow, another month has passed. Time flies. Today I saw an email, one of the, I think, PhD students who started the same year as I did, already graduating. I was like, holy crap. And I took a look at his publication. Dude can publish some paper, man. And looking at myself, I was like, wow. So no, I am not a quality. That's just, I have other things that I like to do. It's just really, it's hard to say. It's hard to say. I guess at the end of the day, it's just the PhD stuff is just not that interesting to me. I mean, I do it just because I have to, but at the end of the day, it's just not that intriguing. In fact, I'll be more interested in what I'm working on right now. That data pipeline stuff. That one is more fun. Now, research is always harder, right? So this, like, you have a solution, you just need to implement it. So the implementation, I really like implementation, and I don't like research. As I just don't like to, write papers and stuff. All right, anyway, let's come back to this. So we're gonna sorted it, right? And then we need to prefix some, okay? And if it's the same, we can skip. Yeah, that's fine. From it's editor tools, right? Yeah. Accumulate. So when I say presum equals list accumulate nums, right? So now what do? We say for any nums, let's do it I n in nums, right? I enumerate nums. And then when I say if I and nums I minus 1 is equal to n, continue. So we don't have to do it again, right? Otherwise, we're going to say windows math.inf. Okay. So what do we do here? We say when the length n equals len nums, right? So what we do is current value. So we have I, right? So I times n, if everything is n, minus presum I minus 1. If I, else 0. Right? So this is on the left side. Plus, on the right side, what's on the right side? Is going to be n minus I. Is that n minus I? Let's see. 0, 1, 2, 3. I think it should be minus 1. N minus I, because we have how many? Well, I'm at I, which is actually I plus 1 number. So yeah, I think this is right. This one times n, but as a smaller, so I'm going to say minus this. Presum, the last one, minus presum what? I plus 1. Right. I plus, no, I. Yeah. So I'm going to do that. So this is the change, right? Change equals this. And we say res equals the minimum change plus, not plus, and then res. And now I'm going to return res. So I see this is O n log n, which shall be fine. Maybe there is even faster, but so far, I guess this is what we can be happy with. 2, 9, 16. Nums min move 2. Run it, pass. Try this. Let's run some. Yeah, cat is meowing. Let's put a 0 here. Might as well. Random values. Alright, I think this one should be right. Ooh. You have been awarded the June badge. See you next month. Thank you very much. We're at 727 days. The goal is 1,000. So we have 273 days left. About a year. A bit less than a year to go. We're going to hit it, right? We are going to hit that 1,000 day goal. I'm a little bit less consistency these days regarding the performance. Sometimes I just do it too late. Just try out each number and compute how many changes are needed. We can sort the nums and use prefix sum to simplify the process of finding the sum in the range. This is O and log n, which give us this performance, which is not too bad. All right, so I recorded another solution, so we can take a look. I'm pretty sure the number of test cases increases. So it's not exactly the same problem. Missed Pokemons 2-liners. Huh, what the hell is that? So we sorted, and for I in range, the first half. What is this? What is this black magic? Okay, I forgot. I said it needs to be learned, but I forgot what it is. And this minus this. He is as cryptic as possible. Oh, it's the same number of test cases. So this is a better solution. Wait, did I come up with a better solution the first shot? No, please don't be that. Oh yeah, I did come up with this. So it's deterministic. What's the reasoning behind this? We sorted it, and then everybody moves to the center. Is that what it's trying to do? So the average is the best. No freaking way. Is there a reason for that? Yeah, we sum all the diff larger than C and all the diff smaller than C. So it transformed to this plus. Oh. I had a feeling that all the changes exactly the. No, they're not exactly. No, I think they are the same. No, they're not the same. They're not the same, but it is the same when it's in the middle. It is the same when it's in the middle. And we don't do it in the middle because we don't do it on the side. Because if we do on the side, definitely everybody needs to, yeah. So we always do it in the middle. Huh. And then, what the heck is that tilde? Tilde is negate, right? What the hell? Wait, what's the tilde? Wait, hold on, what's tilde? I forgot. Complement. The complement. Everything. Oh, it's two's complement, right? It's two's complement. So binary. Nah, this Python using this. I used to know tilde. It's minus x minus 1. Minus x minus 1. Now I remembered. That is the, hold on. That is the way to do it faster. Okay, so I like this, guys. And I'm going to share. Okay. So easier solution, which I actually came up with myself last time. Read this explanation. So basically, the idea is that no matter which value we choose to converge to, as long as it is located inside the array, the change is the same. And if we use a value on the edge, it is always worse. So, and then use Mr. Pacman's trick, where this I equals minus I minus 1 points to the complementary, what you kind of say, to the element same position counting from the other side of the array. So we just need to return sum for I in range len. We have to sort, right? Nums. So for I, actually we just need to go divided by 2, right? So for I in this, you can say nums tilde I minus nums I, and we say this is also correct, which is marvelously, oh the hell, faster. No, I just turned it off. Shoot. Anyway, so variance of a string defined as the largest difference between the number of occurrences of any two characters present in the string. Note, the two characters may or may not be the same. But given, we return the largest variance possible among all the substrings. Okay, so, what we was thinking about is, if we have a unique value, then the largest variance must be the remaining, right? So yeah, so the thing is, if I have at least one unique value, then the largest variance is already done. That is my observation. Now, the problem is, what if we have repeats, multiple repeats? Now, if we have repeats, I haven't figured out a good way to handle it. But we do know is, if we have like a double thing, right? We have a repeat, then I say I can. But then we have the problem, because you have to consider each single one, right? You have to also consider the double on both. All right, and then the hints, not hints, the topic is DP. So we have to try to DP this thing. How do we DP this thing? we have something ending at this, right? And then we say, okay, I can go front until a point where I am the unique one. And then I can compute the variance of that substring. Okay. And then let's say if I am the only one, then that value is the largest variance, right? If I'm the unique one, right, the current SI is a unique one, then the value we found, the variance we found relative to SI is the largest so far. Okay. Now, if I is not the unique one, right, and we have a couple of the repeats previously. Now what happens is that this one, we can compute the substring where I am the unique one. Okay, so that one will be the maximum as well. And then we have something in front, right? Something in front. And that one has this thing as well, which also give it the best, right? So now the question is, from this to this, I'm the best. From this to this, that is the best, okay? So what is the best up until here, overall, globally? Now, if these two letters are the same, then booyah, we can add them together. All right, we can add them together, and then that is the solution, if they're the same. If they're not the same, okay, if they're not the same, do we have to consider secondary? Yeah, it just doesn't feel right because what do I do? If it's all the same, the result is 0, and boom, first B comes here, and then we have 1, 2 minus 1, and then this 1 is the largest so far. Now we have an A, right? Now we have an A. And now we have an A. Oh no, previously 2 is the largest, right? And A, let's also say we know it has appeared before, right? So we know it has appeared before. How do we know the largest currently? Well, this doesn't equal to B, right? If it doesn't equal to B, and we know the maximum at B, if this contributes to its maximum, then we can increment. If this doesn't contribute to the maximum, then it remains the same, remains the maximum, right? So here, and we see, okay, A contributes to the maximum last time. So now we have 2, right? We have 2. Now we come here, It's a B, right? And then previously, the maximum is 2, and the point in contact is B. And now B is the same. Now we have a repeat. Okay? Then it has to minus 1 if we still take B. What if we take A? Yeah, we can ask the question, can we take A? What are you saying? At each point, if I know all the counts that has appeared before, what are you saying? We want a max heap and a min heap. We want a max heap and a min heap as we go through. And now we take a look at the max heap, take a look at the min heap. Think again. What are we doing? At each step, we throw in one more. At each step, we throw in one more, right? And as we throw in one more, up until now, maybe we can use that. Maybe we can do max, maybe we can run 2 heap. Like, seriously. I think we can. I don't see why not. So here is my idea. Right? I want you to say min h and a max heap. Okay, a min heap and a max heap. And then we have a counter. Default. We can actually just say counter. Because it's fine. It's absolutely fine. Okay? And then here is something very, very interesting. We're gonna say for letter in S, so counter letter gonna plus equal 1, right? And then heap q dot heap push main heap. What do we push? We push counter letter and letter main heap, and heap q dot heap push a max heap. We do minus counter letter. Right? Is this the min count? Oh no. Wait, hold on. No, it has to be in the same substring. Because what could happen, now this is just do overall. Nah, this is not gonna work. This is overall up until this point. We start from here and up to here, then we can use it. But we won't be able to tell any of the things in between. Now the question is, do the things in between produce a better result than the overall? It might. Yeah, it might. But the final result is some substring, right? It will end at some value, right? It will always end at some value. And we can compute within this what's the maximum frequency and what's the lowest frequency in this range. Now the question is, how can we compute a substring range? Right? A substring range. Now think about it. If this substring produces the best result, okay? I can see how that's going to be. Let's say we have a bunch of A's ending at B, and then we have a bunch of B's at the beginning. Like B, 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 A, A, B, right? So we know it's going to be this substring. Yeah, let's call it. It's going to be this substring. It's going to give us the maximum. So at this point, how do we know that it's going to be this? Because I see myself as a unique one, right? And I also know the previous me is appeared here, so this will give me the largest. I've tried that. Nah, this is not gonna work. This heap thing is not gonna work. No maximum over here, and then this is gonna repeat. Or I find out this, and then if I have a repeat, if I have like three repeats, a current repeat, I find out what is the maximum counted to this, and I'll include it. I find a maximum of this, right? So for each one, what we need to know is in this range, what is the maximum count? So I want to know the maximum count at any interval. At any interval, what is the maximum count? Now, if I keep counting for every letter, remember, there are only 26, okay? Actually, it should be maybe even less than that. So let's say we have all the counts, all of them are prefix sum, right? And then, given a range, I can go through all of them 26 times, which will give me the maximum count at this. And then, once we get that, right? Once we get that at this and this, right? At a certain range, we have the maximum count. We get that, and then I compute, and then we do this, we do that again, we do this, we do that again. But that's starting from here, right? Hold on. I feel like almost there. Because this is the substring ending at this, right? We're talking about a substring ending at this. Now we're going to find out the maximum possible. It has to end this. All the strings ending at this. So just all the string ending at this. Right? We can include this, which is fine because the other things are already considered. So just do this, jump here. So every time I just do a jump. Every time I just do a jump, including all of them, then we just need this range. Right? This range. And then we move on to the next one. Okay, this one is more likely. And let's do this. So, what do we need? Change idea, huh? We have to go default dict again. So the idea now is prefix count. Right? The default dict was a list. And for letter in S, right? For letter in S, if letter not in pre-count letter dot append 1. Because it's the count. That's the first count. No. If we append a 0. Hold on. For letter, should be all of them need to, because we're trying to build a prefix, right? So you know what? I think we have to go lambda and then return a 0 times linus. Oh shoot! That is going to be big. In fact, we're gonna go enumerate, right? And then here we're gonna make a little bit larger, +1. Okay. Then we can just say pre-count letter, right? Pre-count letter I plus 1 equals pre-count letter I. So I starts with 0, right? And then in the pre-count we always go +1. So this one equals actually equals this +1. I don't know what I was doing. And if it's not, then it's just 0, 0, 0. But dang it. Uniques set S. Okay. So and then for u in uniques. Right? Now we say if, no, we don't have to if, we just say pre-count u, this equals pre-count this plus integer u equals letter. If it's equal, then we need to minus plus 1. Otherwise, it's just the same. And then we go to the end. And now we're going to test it. Well, to go step by step. Right? Seriously, step by step to ensure that we're doing everything correct. Actually, I might still want a counter. Because I can fast charge it. I'm going to just say counter s, right? What the heck? Counter equals counter s. And now we say if min counter.values equals 1, then when we return max counter.values minus 1. Boom, done. No problem. This is right. Otherwise, then we have a prefix count at the default dict of this, and the enumerate and for u in counter. Right? This plus this, blah blah blah, and then we're gonna print out pre-count just to see how it goes. Solution, oh my god, man, come on. That was disappointing. That should be S, and then this one is largest. So A is 0, 1, 2, 2, 3, 3, 3, 3, B is this. Okay, perfect. Now, what we're gonna do is go through them one by one. All right, and we need to record. Where do they occur? Right? So we have to also do a indices equals default dict. This is the list, which is fine. And we're just going to say indices letter dot append I. You know what? It might be better just do I plus 1. Just saying, right? Just saying. And then we're going to do this one more time for I letter in this, right? If it's just 1, it's fine. So we can actually say for I in range 1 to len s, right? And when we get out, we are going to go through all that. So we're going to have a rest here, right? So we're going to get out. We find a previous one, compute, put it in. Get this one, get the next one, compute, put it in. Next one, compute and put it in. Okay, so here's what we do for I, and then I'm gonna say for j in indices oh, we shall do it not here. Shall do it here. All right, do it here, and we're gonna start with 0. It's fine. So for I in this, right, and for j, in indices si, right, blah, blah, blah. And at the end, we say indices si dot append I. Okay? So for j, so this indices array does not contain I. If we go, actually, have to go back to the front, right? So we have to do this like that, the reverse style, right? Reverse style. So we have to go reverse from this one first, right? So that's the previous one. So j, right? J and I. Now what? So these are real indices, right? These are real indices. So we have this index is the previous occurrence. Then I need to find out the maximum. And I also need a count of the current. So I have, let's say, C equal to 1, right? And for J in indices, right now we find out this one comes out. Then I can find the number of counts between, right, the maximum count between I minus 1 and j plus 1, okay? From I minus 1 to j plus 1. Now, if these two, and I guess it's fine. Consecutives. Consecutive is going to cost you some time. Can we make it like a little bit better? Because consecutives, if it's consecutives, we just skip. Yeah, because that's just front. Because it's consecutive, there's nothing in between, right? Until we have a gap, right? From here, then we have a gap. So, J, we just say, how should we say? The number in between. So if I minus j right, because this is this one, this is this one. I want to find out the value in between. Or I could, like in this one. So this is I, this is j. I can do I minus j I minus j is the number in between, okay? That's I minus j. So we say if I minus j is equal to c, then we continue. That means it's consecutive, right? Consecutive is nothing good. Otherwise, blah, 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 and then c plus equal 1. So you just count. So if it's larger then, that means there's something in between, right? There's something in between. Now we have to go through that to find the maximum, right? Then we say for, we don't even care, right? We say for PC in pre-count values. Okay, go through that. Now, what we want to find out is PC. Remember, this is I, this is J, right? So what we want is I minus 1 minus PC J. But since we did a plus 1, so this has to be plus 1, and this has to be I. And we need to find out the maximum of this. So we say maximum of this, right? Maximum of this minus C. And then rest equals maximum of this thing. And the rest, of course, right? And then C plus equal 1. Go to the next one, right? So go to the next one, we have a new J, right? And then if they're the same, that means it's still consecutive. Now, here's the thing. What might happen is just, yeah, we only consider consecutive with this. It could be consecutive on the other side. That's one we just don't take into consideration, I guess. Hey, man, what's the point of this, right? Well, the point of this is I can skip some stuff. Consecutives. You know what? We'll consider consecutives later. Let me just use this pretty brute force to handle it. So I have 1, I have 2, I have 3. Well, no, it doesn't matter. And then we go through all of them. Once the last one, right, come out, and then we're gonna do one more. We'll do one more because if the last one last one J is not 0, right? Then we can include everything to do one more. But if J is 0, then if J is 0, then there's nothing we can do. We say just if not J, right? If J is not 0, then we can include everything. We say res equals max, boom, res, right? Maximum what? For PC in pre-count values, and that's just going to be PCI. That's it. Because PCI is from this towards the beginning, right? Which is towards the beginning. Minus C, my bad. Minus C. And once we're done, we do this, blah, 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 we return res. All right. If we are wrong, or if we time out, we're going to do it some other day. Generator must be parallelized. Max, my bad, max of this, then max of this. Unmatched. Too much. Referenced before. Oh, hold on, really? Oh, I don't need this. J ref. You're kidding me. Why don't we just do it? Because only one of them will be affected. All right. I don't know what happened. It is not right. Dude, it's not right. What the hell? Um, how come it's not right? It should be 3, right? What is 3 should be here. And I'm considering this. Oh, I see. Because I'm considering this. I'm using this as the target. Hmm. 2,000 heaps. 2,000 main heap and 2,000 max heap. We only need max heap. I want to keep track of maximum, right? That's what we want to keep track of, the maximum. Now the minimum, we don't need a heap. We just like the unique value, right? Unique value. But how do we know? Oh. Not only that, at each stage, I should have a different value. Oh man. I'll try one more. This is a crazy idea. This is an absolutely crazy idea. We're going to create, at each step, we're going to have 2 heaps. At each step we have 2 heaps. And then, whenever a new one comes in, I first create a new heap. We have a min heap and a max heap, right? And then we're going to go back one by one. Each time I go back, I'll have another like memo table to record its number. And then I'll increment that one and then push that one into the heap, a max heap and a min heap. Do I need to push into the min heap? So it's just up to this point, right? So up to this point, so from this point up to this point, right? And I have some records, and then we will push it in. And then if the top is the same, I'm going to pop it. If it's not the same, then I push it in, but it's not the same, I just pop it. But next time, if I pop it, all we have to say, I have to clear it out. If it's not the same, then I have to pop, 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 pop until the same comes. So I also need to, so at each step, and then we have O(n) squared. It's not login. Oh,